Okay guys, so today I'll be continuing with differentiation, but now I'll be explaining different notations of differentiation. So the first one that we already did is f of prime x. So we call this first derivative. So if I say find the differentiate f, for example, f it can be any function. You should suppose to say f of prime x. This means first derivative, or you can use this, or you can use this one, d over dx. D over dx basically means differentiate in terms of x. And if I say dy over dx, what this basically means is go to the y function and differentiate in terms of x. So these are different types of notation that can be used to say you are differentiating. Another one that I want to talk about, which we see it in exam papers, is this one. When I say dx and then I say maybe something like x cubed plus 2x, I mean differentiate in terms of x of this function or whatever which is inside. So if I'm giving you this, how will you answer this? You will say, when you differentiate, you'll start by saying d of x is equals to 3x squared plus 2. Same thing, good. This one and this one are very similar. So if I give you d over dx of maybe 3x4 minus 3x squared plus 2, then you will start by saying d over dx is equals to, and then this will be 12x cubed minus 6x, and then remember derivative of a constant, it's a 0, so this is where we'll end. I want to talk about different types of questions that can be asked. For example, if you go to your notes on page 3, I want to try number 1 notation and more notations. Number one from notations. We are given d over dx of 2 square root of x plus 2 over x. So I mean differentiate in terms of x. I'm not saying dy over dx because this is not a y function or any function. It's just an expression. So I mean go to this expression and differentiate in terms of x. So looking at the expression, I cannot start by differentiating because it's not in a standard form. So I will start by saying d dx, and then I try to simplify it first. Remember, square root of an x is like x to the power half plus, and then remember from algebra, if I take this up, it will be a negative exponent. So I haven't started differentiating. You can see I'm still keeping the d over dx. So I haven't differentiated yet. I'm rewriting it in a standard form so that I can be able to apply my differentiation rules. Then after here, that's when I start differentiating. Then I can say d over dx is equals to, please don't say d over dx is equals to if you are not differentiating yet. Then half multiplied by 2, that will be a 1x, and then half minus 1, that will be minus half. Then this one, when I multiply this in front, I'll get negative 2x, and then I minus 1, this will be negative 2. Okay, I'll continue on the next video.